Hello everyone and welcome to the lecture on kubectl request and limits command. So first we'll set the alias k equal to kubectl, running a pod with request and limits. But first I will talk about the CPU units and the memory units. So we have some precision and standards. So we use the suffix m. M stands for millicores. So 1000 millicores equal to 1 vCPU or 1 CPU core. So example, if you specify 500 M, which is 500 millicore, which is the standard, or you can use 0.5 CPU, which is also valid. So you can use one of the syntax. One trap is avoid mixing notations. For example, 0.1 versus 100 millicore to prevent confusion. And in the exam, or usually when working with request and limits, basically it is better to stick with M notation, which is safer and more standard. Second is for the memory units. So we have binary versus decimal. So usually we use suffix mi, which stand for maybe bytes. So 1 megabytes equal to binary, which is like binary base. So it is 2 power 20 bytes, which is a standard convention. So 1 MIB equal to 2 power 20, which is equal to 1,048,576 bytes. We have one more, which is suffix m, but we don't use this. This stands for megabytes, which is decimal base. This is 10 power 6 bytes. This is also accepted, but it's less common. So 1 MB is equal to 10 power 6, which is 1 million bytes. So usually we use megabytes. So example are 128 megabytes, 1 GB bytes, and 1 TB bytes. So one trap is 1 GB bytes equal to 10 power 9 bytes versus 1 GB bytes, which is 2 power 30, right? So 220, 1 KB bytes will be 2 power 10, 2 power 10, 2 power 20, which is maybe, and this is JB, 2 power 30. And this, if you have misunderstanding, it can lead to out of memory error. And these are invalid, 128 MB and 128 GB. So this is invalid. So the syntax is, you will run this command k run pod name, the image, and you will specify the request and limits. So you will specify CPU value and memory value and then the limits. So request is what it is initially asked from the Kubernetes scheduler, like how much CPU and memory it needs, and limits are basically upper limit, the maximum, right? So it can go up to this CPU and memory values. So example is k run. So pod name web test, we are using the Nginx Alpine image, and we are requesting initially CPU equal to 100 millicore, memory equal to 64 megabytes, and it can go up to CPU 500 millicore, and it can go up to 128 megabytes. So you will get an output saying that the pod is created, and the resulting YAML will have this particular resources section. So you have limits, which is the upper limit, and what is initially asked for. So this is the whole YAML. Now I'll talk about the quality of service classes. So there are 3 classes, quality of service. First one is guaranteed. So here every container in the pod has memory and CPU limits and request set and limit equal to request. So basically we ask initial and maximum exactly same. So this will guarantee that pod will run. It will either run or not run, but it will never get evicted. So the scheduler behavior is, this will get the highest priority and there is a guaranteed isolation. And eviction will be lowest, only evicted if they exceed limits or node fails. So this is good in situation where you are running mission critical pods or deployments, because even if some other pods start consuming more memory and your pod or deployment start asking more memory, it will still run, because you will not see any out of memory error, because this is guaranteed. The minimum and maximum is already logged and it is guaranteed. Next one is burstable. So at least one container has a request or limit but does not meet the guaranteed criteria. Basically here the request is lesser than limit. So schedule based on the request can burst up to limit. So it starts with lower value, which is the request, and go up to the limits. Eviction priority is medium, evicted once best effort pods are gone. And last one is the best effort. So no, in this case, no request or limit are set for any container. And scheduler behavior is can use any free resource on the node. Eviction priority is the highest. So this will be first evicted in case there is a requirement. First be killed when node needs resources. Because this is best effort, it will get immediate, but it will get evicted also first. This may get time because it has to get both satisfied, but once it gets scheduled on a node, it will run and this will have the lowest eviction priority. So highest, medium, lowest. So first I will take example of guaranteed when both equal, right? CPU and memory. So K run, for example, mission critical. This is a pod name. The image is Nginx and request and memory 1 GB bytes, and we are setting the same. So this is guaranteed. Next is a burstable when requests are less than limits or limits are set without request. So there are two conditions. So request less than limit or only limit are there but no request. So request default to limits. So K run web image Nginx and we are requesting CPU 100 millicore, memory 128 megabytes. So 100 we are going till 200 and from 128 megabytes to 256. So this is burstable. So burstable, as the name suggests, but it can burst up to, right? It can burst from here to here. Last one is the best effort created when no resources are specified. So you can just say K run best effort and you run a pod with Nginx. So this will get the most likely it will get scheduled immediately, but it will get, if there is a requirement, it will get evicted also first. Next is the complex multi-container pod. So let's say there's a task like create a pod with 2 containers and the container name is app, which is Nginx, and sidecar, which is the busybox image. Where app requests are, so app is the first one, Nginx. It is asking for 100 millicore CPU and sidecar is requesting for 50 millicore CPU. So solution, you use krun only supports one container configuration via flag. So when we use krun, we can only specify one of them and you must use dry run and then we have to edit the YAML. So let's say we use krun multipod and this will be the Nginx, which is the app, right? And request, we are requesting for this particular. So we have to add the container later. So CPU 100 millicore, we are doing a dry run and saving it to a pod YAML. So we have done the first part. So this part we have taken care. Next we'll get the output saying that YAML is created actually. So this will go into the pod YAML file. Not this point the YAML is not created. Sorry, pod is not created, I meant to say. Now after we get the YAML from here, we will inject the second container. So this is the resulting YAML without. So here you have the Nginx image and the name is multipod. It is derived from here. And we got the first one for the Nginx. So CPU 100 millicore, we got this part taken care. Now modify the YAML to add a second container, which is name is sidecar and image is busybox and 50 millicore. So what we'll do, we'll edit, and so as per the requirement, we have to match the task. So we are changing this name to app. This is what we need, and this is already taken care. And then we add this section, the whole section. So image is busybox, name of the container is sidecar, and under resources section, we are requesting for 50 millicore CPU for this second container, and this is the first container, right? Okay. Next is request and limits does not work for deployment. So we cannot use direct like krun for deployments. So what we have seen is for the pods, like standalone pods. So while krun handles pods, the admin and application developer exams predominantly focuses on deployments. So there is a critical limitation where k create deploy is that it does not support same like pod. It does not support these two flags, request and limits. This forces a candidate to adopt alternative imperative workflows. So what you need to do is, first option, so there are two options. Create the deployment directly with request and limits. So you can do like this. First, create deploy web app image nginx and replicas. So we have just creating a deployment. We'll add the request and limits later. So step 1, then modify the deployment to add request and limits using, so there is a kubectl set resources command. So now this is in the system, this deployment, and we can use set resources deploy, so web app, and we set the limits, CPU and memory, and the initial request. So this will modify the deployment. Second option is to first generate the base manifest YAML file. So we can do create deploy web image replicas and do a dry run and save it to a YAML file. Then we inject the resources. So we have to go to the specific section where we modify the YAML file, and under the container section, so we add this whole section. So we are adding the requests and the limits, and then apply the modified manifest. So make sure you run apply because the deployment is still not saved to the system or to the database. So you'll get a message saying that deployment is configured. Next is how to target specific containers. So this is a complex scenario. The deployment backend, for example, has two containers, app and one more container, log agent, and you only want to increase the limit for app. So there are two syntax, basically set resources deploy backend, and you can do -c app, and you are setting some limits, for example, memory 1 GB bytes. Second syntax is basically same, but you can use -c and sidecar. So specifically equal to or space, and we are setting a limits. And that's all. Thanks for watching.